And good evening from Philadelphia. Frank here with a late night edition of UFO News Network Sunday. We got in just under the wire 2 minutes before midnight tonight, but we're all ready to go. We've got a great special guest with us tonight, making a second appearance, and he has had a very interesting year. So let me get to my co-host and bring her on, Chant Hannah. Chant, how's everything going tonight? And why don't you bring on our special guest?
It's going really well, thank you. We have a wonderful guest tonight. His name is Professor Kevin Knuth. He's an associate professor in the Department of Physics at the University of Albany and is the editor-in-chief of the journal Entropy, MDPI. He is a former NASA research scientist, having worked for 4 years at NASA Ames Research Center in the Intelligent Systems Division, designing artificial intelligence algorithms for astrophysical data analysis. He has over 20 years of experience in applying Bayesian and maximum entropy methods to the design of the machine learning algorithms for data analysis applied to physical sciences. His current research interests include the foundation of physics, quantum information, inference and inquiry, autonomous robotics, and the search for and characterization of extrasolar planets. He has published over 90 peer-reviewed publications and has been invited to give over 80 presentations in 14 different countries. Thank you for being on the show with us tonight, Kevin.
Oh, thank you very much for having me.
You'll need to correct me on something here. I had a little trouble saying a word. I think you heard me when I struggled a little bit with in applying Bayesian. What is that?
Bayesian is how you pronounce it. Yeah, it comes from the Bayes theorem from Thomas Bayes, and so it's a theorem in probability theory.
Fantastic. Thank you for clearing that up. And I understand that you've been involved in science probably for most of your life. Can you please tell us, why did you decide to go ahead and embrace the world of science? What was the impetus for you to have the desire to get involved in this topic?
Oh, I think that probably came from my parents. My parents both nurtured my interest in science. My father especially introduced me to the theory of relativity when I was rather young, maybe fifth grade or so. And he had given me a popular book written by Einstein to read, and I just devoured that book and really was very interested in that. So that's mostly where it came from. I also was born at the right time. I was born in 1965, so I barely remember the moon landings in 1969. I was 4 years old, and I remember being at my grandparents' house watching it on television, and everyone telling me, this is so important. This is the most important thing that's ever happened, and it really had an impact. And so I think, there's several factors that went into that, but
that was an important year. And I also I'm glad you brought that up because that period of time really allowed a lot of kids to look up to certain people. The folks that were involved in that huge project, a lot of them became heroes for the general public to look up to. Did you have any role models or anybody during that period of time that you felt were role models to you? And also, in addition to that, did you find yourself looking up in the sky more?
Yes, certainly. I mean, the Apollo astronauts were certainly role models. That was really an enormous event, and also Albert Einstein. I think those, reading about relativity, and I found it just fascinating. And I recall one of the really strong memories of the moon landings was we were heading home after watching it on television, and it was late in the evening, and my father was carrying me. I was only 4 years old, and I remember we paused outside before getting in the car, and he pointed up at the moon, and he said, "There are people up there." and I remember just looking and thinking in wonder, wow, that's amazing. There are 3 people up there. And it's something that, kids today haven't ever experienced, and I think it's a shame. And hopefully we'll experience again soon with the upcoming Artemis missions.
Yes, and I'm glad you brought up the Artemis missions. What do you feel will come of those missions, and what do you think is inspiring them to be engaged in such a serious mission that means a lot to the whole world?
Yeah, and tell us a little bit about the mission too.
Yes, please.
From what I understand, the idea of the mission is it's going to be a stepping stone to Mars in some way, and the idea is that we're going to go to the moon and not leave. We're basically going to start setting up a base there, which I think should have been done decades ago. The Artemis mission, I was glad to see that they're going to have at least one female astronaut. I don't know why there can't be 3 female astronauts on the mission. I think that would be fitting since Artemis was the sister of Apollo. So that would be interesting as well and important. So, but I think that's hopefully we'll follow through and it'll be a great mission.
Oh, thank you for answering that. Do you feel like we have any more missions that we can endeavor to pursue aside from this mission right now?
Well, there's the missions to Europa to study the surface of Europa and get some idea of what the subsurface oceans are like. The missions to Titan, I think, are very important to get some idea of what the environment on Titan is like and whether it could harbor life. It could be very different life than what we would expect on Earth, but that would be very interesting.
Yeah, I'm glad you mentioned that, Professor, because if we find that there is some life, even at the lowest level, bacterial life, or even like a crinoid, or who knows, maybe even some sort of a vertebrate sea life on those planets or on those moons that orbit, Enceladus orbits Saturn or Jupiter. I can't recall.
Yeah, Enceladus orbits Saturn, and it also has subsurface water as well. So, yeah, these are all very exciting places and very interesting places.
So if we find life, and we know there's life here, so there's life on 2 bodies in this solar system, I mean, that pretty well bodes for life being pretty common out there, I would think.
Yeah, I think so. And I think this is the interesting thing. The contrast between Earth and Mars to me is striking. Mars isn't horrible, and it's surprising that it's not covered with life. Or maybe you can take the other perspective that it's surprising that Earth is so covered with life. And I when I'm teaching my astronomy class, I point this out, and I often say you can't swing a dead cat without hitting something that's alive here on Earth. And that's really amazing. It's just carpeted with life, and it's obvious that this is a living planet. And you contrast this with the moon, where you're not so surprised there's no life there. There's no atmosphere, so it's in extreme temperature variation. So that's not so surprising. But it's surprising that Mars is as devoid of life as it is. I would have thought that there would have been a better chance for life on Mars, and we still might find life on Mars, but it's clearly not easy to find. But life on Earth is very easy to find.
Yeah, I wanted to actually just jump right into a really serious topic that I greatly admire you for tackling. And that is, I wanted to discuss your talk at Max Planck and go over the paper that you're writing. Do you mind bringing that up, Kevin?
No, not at all. Yeah, this year I presented a paper at the Maximum Entropy and Bayesian Methods in Science and Engineering Conference. It was held at the Max Planck Institute for Plasma Physics in Garching, Germany, which is just north of Munich. And it's a conference I've gone to since 1997, so I've attended, for over 20 years, and I've always been impressed by a number of people at that meeting and how they are always pushing the limits. They're always trying to do something new and interesting, and I try to do that every year myself. Most of my work there has been theoretical, and this year I thought to do something related to estimating the flight characteristics of anomalous aerial vehicles and looking at unidentified aerial vehicles, UAVs, and estimating their accelerations more carefully by looking at a set of cases where you've had multiple witnesses with multiple imaging modalities.
Yes, there's a handful of well-documented encounters, as it says in your paper, including the 2004 encounters with the Nimitz carrier group off the coast of California. And I found that fascinating. Can you go into that topic, please?
Yes, well, the 2004 encounters, I think, have been pretty well publicized at this point. They, for a period of about 2 weeks, the Nimitz carrier group had been detecting anomalous aerial vehicles in the area of Southern California. They would basically appear on radar at about 80,000 feet and drop to around 28,000 feet and track south from around Catalina Island south to near Guadalupe Island off the coast of Baja, Mexico. And in at least one occasion, they had redirected a training mission to intercept one of these vehicles that had basically moved into the training area, so it posed a hazard. And they, so that was the flights led by Commander Fravor. So they visually encountered these craft and described them as large white Tic Tacs, basically a white butane tank-shaped object about the same size as an F-18. And when they tried to engage with this object or get close to it, the craft was described as taking off as if it was shot from a rifle. So it had very high acceleration, accelerations that nobody would survive. The craft was described as disappearing from view within a second, and Commander Fravor noted that even if you have an airplane going at Mach 3, it still takes 10 seconds or so before it gets out of view. So these objects accelerated much faster than their aircraft.
I'm glad you're bringing that up, Kevin. I'm sorry to interject. We had a fascinating discussion with some gentlemen that were on the USS Nimitz and also USS Princeton. And I brought this up a few times with Frank in some podcasts, so I'm sure he already knows what I'm going to say. But that is, I actually asked one of the gentlemen, I think it might have been, Frank will refresh my memory.
It was Gary Voorhees.
Yeah, from the USS Princeton, right?
Yep.
And I asked the group if they felt that the craft that they saw or the anomaly they saw may have been derived from ET technology or was one of ours, so to speak, meaning maybe a government-owned vehicle. And it was really surprising to hear Gary Voorhees say he felt it was one of ours. Now, you just mentioned speed. If it was one of ours, let's just pretend for a second it was, do we have anything that can go at that speed? And like you said, no human could be in a craft like that at that speed, right?
Yes. You could potentially have a drone or something, or an autonomous craft that moves at those speeds. It gets tricky. In that case, there were basically there were several aspects of the encounters in the Nimitz case that I analyzed. One was from the radar data from Senior Chief Kevin Day, also on the USS Princeton, where he was watching these things dropping from 28,000 feet to sea level on the order of a second or so. And they were basically dropping from 28,000 feet to sea level in 0.78 seconds. And so if you estimate the accelerations in that case, you're coming up with numbers on the order of about 5,600 Gs of acceleration, which is really insane. A person can withstand about 25 Gs for very short periods of time. Our fastest missiles that basically can handle their airframes can handle on the order of 50 Gs, and they can continue maneuvering at accelerations of 35 Gs, but that's well below 5,000 Gs. So even if these were drones, it would really be surprising. I don't know. I honestly don't know what to think about it, because you can't rule out the possibility that these are from Earth. You can't rule out the possibility that someone made them here on Earth. I would be surprised that they wouldn't be used more often if they were made here on Earth, because that's really exceptional technology. Proving that something's extraterrestrial is incredibly difficult. A lot of people try to focus on isotope ratios and things like this, but we can manipulate isotope ratios, so that's not a hard thing to do. We know how to do that. That's what we do when we isolate uranium for making nuclear weapons. We're playing with isotope ratios. It's a hard thing to do, but it can be done. So isotope ratios don't prove that something's extraterrestrial. To prove that something is extraterrestrial, you'll probably have to drag an alien off of it. That's probably the only way to really convince anyone, because otherwise, you could get some really interesting tech that no one's ever seen before, but just because no one's seen it before doesn't mean that it wasn't made here on Earth. So it's a very difficult issue.
Okay, and I want to go ahead, Frank.
Yeah, I just want to jump in. We were talking a little bit about the Nimitz case, and you are involved with Kevin Day on a UAP pattern detection mission out near Catalina Island, generally the neighborhood that this case took place in. And I was hoping you could tell us a little bit about how you got involved in all that and what you guys are looking to do.
I don't remember exactly how I got involved in it. I'm really excited that I am. Kevin Day really spearheaded this project, and he's extremely motivated. I really respect him for that. I get that he was involved with these encounters, and he wants to know what they are, and I really appreciate that, and I'm really feel honored to be able to help with this and work on this. So the idea basically is to to go back to Catalina Island and south of Catalina Island with a ship and actually look for these things. The idea was that they had detected them in November of what was it, 2004?
Yes, sir.
And in November, and so we're going to go back at the same time of year and hope that they're still around, or others like them will still be around. And we're going to go with equipment and try to find them, try to measure any qualities we can about them, and get as much information as we can.
And you had mentioned a friend sighting in that neighborhood regarding a green ball of light that actually descended into the ocean in the area. Can you tell us a little bit about that?
That's a great story, but in some ways for me, I really appreciate the story because he's a close friend of mine. We've been friends since high school, and but it's a typical UFO sighting in that when you tell the story, there's always some aspect of this where somebody can ha 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 and laugh it off and just pretend it didn't happen. But my good friend, his name's Joey. I'll just give the first name. His name's Joey, and he was the for a good period of time, he was the head bartender at the Ritz-Carlton hotel in Laguna Beach. And there was one day he was out. It was in the evening. He was out taking a break, so he's out on the patio having a cigarette, I believe, and he was just looking out at the water, and from that point you can see Catalina from the shore. And so he's looking out over the water, and he saw this bright green light. He said he described it as literally shooting down from space. It looked like it came from space and went right into the ocean. And he said it was so fast that had he blinked, he would have missed it. So
okay, sounds familiar.
Yeah, so he saw this thing, and he was stunned and thought, "Oh my God, was that real? Did I really see what I just thought I saw?" And he asked the people next to him. There are people standing nearby. He asked some of the other guests at the hotel if they had seen it, and nobody had seen it. And so he started just running around asking everybody who was outside if they had seen this thing, and he was desperately trying to find someone else who had noticed it, and nobody noticed. And he was feeling pretty despondent about it, and he decided to run up to the restaurant, because there's an open air section, and he ran up to the restaurant and was asking around, and he went to every table and, asked if anybody had seen anything interesting, and nobody had. And there was one table off in the corner, and they were laughing and laughing. And so he was a little hesitant to go over there, but finally he mustered the courage and walked over and asked them, and they stopped and listened, and he told them what happened. And they said, "Oh, we were just laughing because this guy," and they pointed to one of the guys at the table, "this guy just saw a green light fall into the ocean." And so he was vindicated, and so him and the guy were like, "Yeah, it was so quick. It was like a flash. It was just an instant, and it was so quick." And, this poor guy's friends were all laughing at him. So he was glad that, Joey had come over and talked to him, because then he was vindicated as well. But that was all there was to it, So what do you make of that? I mean, well, you can't do anything with it scientifically. It's a flash of light, and you'll hear most people will say, "Oh, it could have been anything." Well, yeah, right. It could have been anything. You're right, but that's what it is.
And unfortunately, most bars don't have radar systems set up there, so they wouldn't have been able to catch
exactly.
that.
Then come the other laughs. "Oh, well, he's the head bartender. Oh my God, yeah. Well, it could have been. How many drinks did he have? And blah blah blah.
Exactly.
Well, he's on duty, but
I'm sure he didn't.
Sure he's on duty,
right? But, yeah.
Now, had you heard this story
how
before?
The conversation can go.
Sure.
Frank,
had you heard this story before you heard about the Nimitz case, or after?
Yeah, this was years ago.
Oh, okay.
This must have been like 2002 or something like that. 2000. It was in the early 2000s, 2001, 2002, right around there.
Okay.
It was while I was working at NASA. So I was working at NASA from 2001 to 2005.
I'm glad he was able to work up the courage to tell you.
Yeah, well, we're good friends. We tell each other all sorts of things. So yeah.
Okay.
No, it's a fun story.
It is. And so I had a few questions for you about the Nimitz, because I was still on that topic, and wanted to ask you a few things about it. And that is regarding the Nimitz sighting. You did or did not rule out that it was ET related. I already know the answer to that, but I want our listeners to hear why you didn't say this is ET technology. How did you come to that conclusion, if that was the case, and why?
Right. I didn't rule it out. Mainly because to show that something's ET technology, you would have to demonstrate that it was developed by aliens. And I would have no way of doing that unless I actually saw the aliens who made it. I don't know any other way to do that. I couldn't easily rule out that some clever person, like Elon Musk or somebody has some secret, or Bob Bigelow has some secret project where they've basically designed this themselves.
Okay.
And so you can't easily rule that out.
All right.
Could be Russian. It could be Chinese. We don't know.
And I'm glad you brought that up, because my next question, that kind of is a nice segue into the next question I have, and that is, I've heard it said, and so this is a stereotype and assumption. It's a blanket statement. So I'm just going to go ahead and preface that, what I have to say with that, and that is, I've heard all my life that the military, at least in first world countries, are allegedly 10 to 20 years ahead of time regarding their technology. So going along that idea, if that's true, does that lend any credibility to the possibility that the Tic Tac may have been one of ours? Is that possible?
It's still possible. It's something I can't rule out. It makes it surprising, because if UE had this technology in 2004, then all the aeronautical engineers in America or in the world are being played for fools. I mean, this breaks all the rules of aeronautical engineering, and so then NASA itself is being played for fools, because we've got these huge chemical rockets that we're using to lift materials off the planet, where apparently we've got, if it's true that somebody on Earth has craft that can accelerate at 5,000 G, at 5,000 G, you can get from one side of the galaxy to the other in a matter of weeks. So this would be really shocking that we would have had this technology now for 15 years and we haven't seen it used anywhere.
Well, I'm
Right.
glad you mentioned that.
I find that surprising. Now the question is that would that be more surprising than it being alien technology? Well, I can't actually say that. So this is still an unresolved issue. We need more data is what we need.
Okay, and I still have another question, and that is, did you get the opportunity to view Dave Beatty's USS Nimitz documentary that he did? Do you feel also was that a good analysis and representation of what occurred?
I mean, from what I've heard from talking to Kevin Day personally, or and from what I've read from the SCU's analysis of the Nimitz case, it looks like Dave Beatty's documentary was actually pretty good depiction of what happened.
Okay. Frank, you had a question. I'm sorry, I interrupted you.
Yeah, you had mentioned the acceleration at the 5,600 Gs would be able to allow somebody to travel across the galaxy in a matter of weeks. That's 100,000 light years. Now, and also you're going out to Catalina. I think that's about right. If I'm wrong, please jump in and let me know.
That's correct. That's correct.
And you're going out to Catalina. There's always been talk about a literal base in the Catalina area. Chase Klutsky went out and did a search with a little mission regarding seeing some underwater photographs of what looked like it might have been a structure. It turned out it wasn't. But there has always been that talk. What do you think about the possibility if there are a lot of these type of sightings and we're getting a lot of them, that it's not entirely just traversing the galaxy, but they're literally right here?
Yeah, well, that's a question I posed to Elizondo, Lou Elizondo, when we were at the SCU meeting. I asked him, I said, from his ATIP studies, were they able to assess whether basically how many of these objects are on Earth at any given time? I said, are there tens of these things, hundreds of these things, thousands of these things present? And he just didn't know. I mean, this would be a very hard thing to collect data on, of course, but so yeah, it's not obvious that there's not a base here. Earth, I mean, let's be honest, Earth is an interesting place. I mean, it's interesting to us. We live here and it's interesting to us. So it's an interesting place, especially compared to the other bodies we've explored in our solar system. So anybody studying Earth, I would imagine that you would spend time here. That would be the sensible thing to do.
Okay, and I did have a question, and that is, can you discuss the attitudes of scientists and the fact that scientists need to get more involved in the kind of topics that we're talking about right now?
Yeah, this is, again, all these things are delicate issues, and one of the difficulties in science is that there are a lot of interesting things to study, and you just don't have the time and resources to study all of these things. I typically tend to take on too many projects because I can't say no to something really interesting. And that means that I don't make a lot of progress on a lot of them because I just don't have the time and energy. But so what you often do is you perform a sort of triage. You look at a problem and you decide whether this is worth studying. And scientists do this all the time. And unfortunately, UFOs have been, triaged and basically thrown into the pile of not worth studying because there's probably nothing there. Now, why is that the case? There's actually a good reason for this. Unfortunately, this goes back to our prior expectations in the 1940s when these things were first, when it was first made publicly known that these things were encountered. So you have, if 1947 was a big year, you had Kenneth Arnold saw the half-moon saucer-shaped craft near Mount Washington. A few weeks later, you have the Roswell incident. Later on, there's a couple of weeks, you have the Puget Sound incident. So you've got a few things going on that made UFOs, where UFOs basically entered the public consciousness in the United States in that year. Now that was not at all the first year that these things were ever seen. You've got sightings going back to the 1800s and before, but this is when the public became more widely known that this was a possibility. And if you consider the situation in 1947, you're 10 years before Sputnik. 2 weeks before Sputnik, the Royal Astronomer in Britain called space travel bunk. That was 2 weeks before Sputnik. So you have a class of scientists who 10 years before Sputnik didn't think space travel was possible. You had a lot of people who seriously didn't think it was even a possible thing you could do. And in 1947, we really didn't have a lot of information about what the planets in our solar system were like. We knew what their atmospheres were like because you can get that information from spectra, but we didn't know whether there was life on Mars or not. I have a little golden book of the planets that has a picture of what Mars might look like. And that book was written in 1968 and has all sorts of weird life forms on it, in the pictures. I like showing that to my astronomy class because it really highlights our state of ignorance. So we didn't really know what the planets were like in 1947. And we didn't know whether there were any planets around any other stars. That wasn't known until the 1990s when we first discovered exoplanets, and that didn't really take off until the 2000s. So in 1947, we really had no idea what the universe was like. We didn't know it was possible to travel through it. And could UFOs be alien spacecraft? Well, probably not. That would be the most reasonable assessment. I mean, especially if you're of the belief that space travel is impossible, it's much more likely that UFOs are something else. And so that attitude basically prevails to this day, despite the fact that our prior information about the universe has changed dramatically. And despite the fact that we ourselves have visited other worlds and are planning our own interstellar missions, NASA is planning to send a probe to Proxima Centauri on 2069, the 100-year anniversary of the moon landing. So we are now beginning the first steps to interstellar travel ourselves. We're going to do it. We're going to make it happen. And so what's interesting to me is that despite the fact that our knowledge about the universe has changed and our knowledge about the possibilities has changed, that scientists still think that this is unreasonable surprises me. And it especially surprises me when there are SETI efforts going on, especially SETI efforts that are involved in looking for alien artifacts on the moon and Mars and asteroids. And, the thinking there is that if you want to observe Earth, you can set up the idea is that they might have set up some observation base on the moon to observe Earth, but anybody who's worked with remote observing knows, and I've done this at NASA, it's much better to get ground truth. Why would you travel light years to set up a base on the moon and study Earth from the moon when you can actually land on the Earth? Much better to be here. And so now this answers, several questions, because this is, now we're back to, could there be a base here on Earth?
Yeah, I mean, if the number of really wild, unexplained cases with the sort of flight characteristics they picked up with the Nimitz are out there, you got to at least consider it anyway. But I was looking at one of your slides that you presented at the SCU, and you cited a paper, How Rare is Complex Life in the Milky Way? Can you answer for the folks at home, what was meant by complex life? What are we talking about here specifically?
Oh, I think they meant things like multicellular organisms. I don't remember the details from that paper, but they basically were doing simulations of chemistry and biology, and along with some statistics of the known exoplanet statistics to try to get some idea of where you might expect to see.
And then primitive life would be something like bacteria, maybe?
Yeah, bacteria. Yeah,
Okay.
Something like that. Yep.
Okay, yeah, and actually had an odd question for you. And not that the topic we're talking about is super normal, but the topic, the question I had for you, Kevin, is I wanted to know, do you believe that if there are ET civilizations, whether it be in the singular or plural, are on this planet already or visiting our planet, whatever manner or presence they have here, do you believe that they have a military?
I mean,
Would they be that organized? In other words, do you feel that they're capable, since they could be ahead technology-wise, let's just assume they are, do you think that they would be that well, I don't even know if the word sophisticated would be very good regarding that, but do you think they would be organized in that manner or structured in that manner, their civilization?
Yeah, I don't think I would like to speculate on what aliens could be like in this sense. There are some hypothetical situations you could consider, but
So what do you
I
imagine
think
there? Go ahead.
I think that given the observed accelerations and the technologies that I imagine you would need to have to be able to pull something like that off, I can't imagine that if they wanted to, they could be a threat.
Mhm.
Now, what kind of threat? I don't know. I don't know why anybody would take over a planet or something like this, like you see in science fiction. I think that's kind of a silly notion. But I think that if we threatened them, then they could certainly be a threat to us.
And see, that's actually why I'm
I think
bringing this up. Go ahead.
yeah, but I hesitate doing that because I watched, I didn't watch all of the episodes from the TTSA documentary Unidentified, and I
Hmm.
was nervous about that when it was finished because the overall themes seemed to be focused on them being a threat. Now,
That's exactly what I was
on
going to
one
bring up.
hand, I get that because the ATIP studies were Department of Defense. That's their job. Their job is to assess threats. Fine, and they did their job, and I think that that's excellent. And so on one hand, that's good. On the other hand, I think it's important for people to realize that military studies or Pentagon or defense studies are not scientific studies. Scientific studies are different. They have different goals. They have different questions they want answered. And so I know a lot of people look to ATIP for information and answers and data, but they're not going to be able to answer everything that we're going to want to know. That's going to require scientific study. And science works best when people cooperate and share data and share information and share ideas. That's when things work best. And from the way a lot of black work is conducted, you end up with scientists working in pairs where they can only talk to each other, or some limited group of people, and they can't share information. And I don't see that as always being effective. It's effective from a secret standpoint where you want to keep things quiet and you want to make progress at the same time. But at this point, I don't think it's useful to keep this stuff secret anymore. I think that we all need to know what's going on, and I think we all need to work on this. I think it's potentially a serious issue.
Yeah, it's hard being a human and wondering about a different civilization that isn't. And so my naive mind, I kind of, in a wide-eyed manner, look at a different type of civilization, and I assume that they could be, I'm just pretending, millions of years ahead in their technology. And if that's the case, I wonder, would they have evolved past the point of needing a military? Uh, And if not, why? But anyway, I wanted to ask you a question, and that is about radar. Is radar proof of anything, Kevin, regarding an anomalous object in the sky? And if so, how can it be used to prove anything? And then we'll go into what proof is later regarding science.
Well, radar is a piece of evidence. It doesn't constitute proof by itself. To really, what you really want in these situations is you want multiple imaging modalities that all concur. And so when you have somebody like Senior Chief Day picking these things up on radar, and then instructing, Commander Fravor to go to this location and see what this is, and Fravor gets there and actually sees an object that's anomalous, then these things concur, so, and, or the subsequent flight that went with the ATFLIR with the infrared imaging and actually captured infrared images of the object. And while it's true that, as some of the more publicly prominent scientists have noted, when discussing the ATFLIR videos, they basically throw their arms up and say, well, it could be anything. It's a blurry image. Well, of course it's a blurry image. It's an infrared image. What do you expect it to be? Of course it's going to be blurry. But it can't be anything. That's the issue. I mean, I think, my favorite explanation that I had somebody throw at me was maybe it's a highly reflective bird. Now, that I had to laugh. They don't know. I've been a bird watcher since I was 5 years old. So for me, this is really a stupid thing to say.
A bird that goes at Mach 3.
Yeah, exactly. Or well,
Faster than that.
Faster than that. I think the top speeds you were looking at are, looking at Mach 16 or something like this in some cases. So that's ridiculous. Saying it could be anything is ridiculous. No, it can't be anything. It is something special, though. What it can't be is it can't be an F-18, and it can't be a MiG. So, and it's not a missile. So that's of interest.
Okay, I do have a question that I am so glad I thought of. I didn't want to forget this. and I want to know, how do you translate this into a scientific observation? And that is this. When we were talking to the gentlemen from the USS Nimitz and USS Princeton, a few of them mentioned how there were some people that came onto their ship and coveted that information, meaning the anomalous object that they all witnessed, and the recorded imagery of it. Now, my question to you is, since you're so deeply involved in this topic from the side of science, how do you then insert that behavior into your science paper if you were to cite it? Because, you're talking about humans and their reactions, but still, it's important that there are people coming on board these ships to grab that data. Does it matter to science what they did? Because, if that's one of our own objects that we're commandeering, why would we then have our own go grab that imagery?
Well, yeah. So now we have to hypothesize what the intent of those people were and what their motivations were, and that becomes challenging. What's surprising to me is the fact that they knew that those encounters took place. And from the people from the Nimitz that I've talked to, that is also surprising to them. So that would lead me to believe that there is then a higher probability that whoever these people were knew about these objects beforehand, possibly because they were their objects and it belonged to them or their program. Now, I would worry that, if you have another military program going on and you've got craft flying around that are basically interfering with training programs in the Navy or interfering with Navy pilots, buzzing past their planes and putting them in danger, That doesn't sound very legal to me. I'm not an expert in legality of these issues, but that sounds dangerous and foolish in many respects. So,
Well, that's why none of it
Yeah,
makes any
and
sense.
I do know that there are real strict limits in terms of, let's say, breaking the sound barrier, for example, for any
right,
of those military craft.
right. Yeah,
So,
well, in all
go ahead.
these cases, in all the cases I looked at, the airplanes were approached at close proximity by these objects, and that's a safety issue. That's Richard Haynes, who was also formerly from NASA Ames, had set up
Right.
NICAP, which is reporting
Yes.
agency, an anonymous reporting agency for pilots,
Hmm.
because he was concerned about aviation safety issues, and this is an aviation safety issue. And so I find it frustrating when I do encounter scientists and others who blow this off or try to blow this off and say it could be anything. Well, we need to look into it because this is an aviation problem. You're going to end up with a downed pilot, or you got passenger jet pilots seeing these things.
Hmm.
And I don't want to be in a plane flying, from New York to San Francisco and have my pilot have to evade some approaching unknown aircraft. I don't want to have to know. I mean, I'm not going to know about it because they keep it quiet, but I don't need my pilot on edge because that happened.
Well, so
And
then,
so these are things that should be worried about, and Congress should get involved. This is really why Congress should be involved.
right. And so I don't mean to be
Yeah,
redundant.
Professor. Yeah,
but
let
go
me
ahead.
jump in here real quick,
Go
Chant.
ahead.
And
Yeah.
you had mentioned Congress being involved. It seems like the Congress people who are interested and are getting briefed on this issue are folks that are members of various military-related committees and not the science.
Right.
Are you a little disappointed that the scientific committees are not taking a closer look at this?
Yes and no. I understand it. I think that the belief, the first concern is that these things are Russian or Chinese or, from some other nation. And that, I think, is probably their first concern. And that's probably the reasonable question to ask first. Once that gets resolved, and if we find out they're not Russian or Chinese or anybody or belonging to anybody else, then the question comes, who do they belong to? And then I would expect that scientists will have to get involved. I would like it if scientists had been involved from the beginning, basically from when the SETI project started. These things should have been looked at along with looking for radio signals from other worlds. I mean, if you have aliens here, that's definitely something you want to know about. you don't want to be surprised by that. So this is something to look at. It's something to look at and look into. Look into it seriously, assess it, and then go from there.
So, Kevin, I want to niggle you about something and kind of like see if you'll allow me to be redundant with you.
Okay.
And that is, I want to know, how do you feel about the possibility of this Tic Tac being one of ours and invading our own airspace, so to speak, in a manner that would put people in jeopardy, that would be illegal? Does that sound like something we would do? I mean, that just sounds odd. Why would we do that? I'm not expecting you to answer that. And then also, wouldn't it also lend to the more to a possibility that it could be not one of ours, so to speak, but something else?
I can't really hypothesize about the motives or actions of in people or groups in our government. I mean, I can just say Tuskegee experiment and we're done with that conversation. So
okay.
yes.
Yeah. Now
people do those things, and that does happen. So it is a possibility.
Well, thank you very much. I wanted to talk about the conclusion of your paper, and the paper being estimating flight characteristics of anomalous unidentified aerial vehicles. Now, I just wanted to read a sentence or two from your conclusion. In fact, is it okay if I just read a good part of it? Is that all right?
Oh, yeah, that's fine. Yep. It's not published yet, but that's fine.
Thank you very much. I appreciate that. Regarding your conclusion, it says, it is difficult to draw any useful conclusions at this point. We have characterized the accelerations of a number of UAVs and have demonstrated that if they are craft, then they are indeed anomalous, displaying technical capabilities far exceeding those of our fastest craft and spacecraft. It is not clear that these objects are extraterrestrial in origin, but it is extremely difficult to imagine that anyone on Earth with such technology would not put it to use. Moreover, observations of similar UAPs goes back to well before the era of flight. Collectively, these observations strongly suggest that these UAVs should be carefully studied by scientists. Unfortunately, the attitude that the studies of UAVs, UFOs, is unscientific pervades the scientific community, including SETI, Search for Extraterrestrial Intelligence, which is surprising, especially since efforts are underway to search for extraterrestrial artifacts in the solar system, on the moon, Mars, and asteroids, and at Earth-associated Lagrange points. Ironically, such attitudes inhibit scientific study, perpetuating a state of ignorance about these phenomena that has persisted for well over 70 years and is now detrimental since answers are presently needed. What a really impactful, powerful thing that you said there, Kevin. Can you please tell us a little bit more about that conclusion that you did?
I don't know. I basically say it all, I think.
You did?
I think that just summarizes it. I have to say I wrote that a couple weeks ago, and I keep going over the paper because I'm still making a few edits to it, and I still really like that conclusion. I think it hits all the points that I wanted to make.
Yeah, it hit home really well. Thank you so much for having allowed me to read that. And this paper, a kind of a funny question, how long did it take you to write it?
Oh my gosh. Well, if you include doing the analysis of the data, probably I've been working on it since March or so. So I guess it's been about 4 months or something like that, 4 or 5 months.
Now, I noticed that you brought up the extraterrestrial hypothesis. That would be Jacques Vallée's hypothesis. Why did you do that?
Because it's a question that's going to come up when reading a paper like this, so I thought I should at least address it. And I basically say what I had said earlier, that proving that something is extraterrestrial is extremely difficult. And
right.
Yeah. And
I'm glad you brought it up.
You aren't going to prove that with data, even like that, even this data here. You know, the goal of this paper is to start building a body of scientific evidence, and so that we can come to some real understanding of what these things are, and do something about the state of ignorance that's persisted for over 70 years. I think being this ignorant about something that is now clearly this important, shows some level of irresponsibility on the part of scientists and lawmakers.
I wanted to bring up. Go ahead, Frank.
Yeah, I just wanted to ask, you'd said that you are working to model nomadic relativistic travelers, which I'm assuming is going to mean just basically interstellar travelers, and eventually have a research paper on that topic. And your goal is to model different societies with different characteristics. So can you tell us a little bit about that? Yeah,
so that was based on a talk that I gave at SCU in March. At the SCU meeting in March, and one of the difficult there's several difficult aspects here when it comes to talking about what we expect extraterrestrials to be able to do or accomplish when it comes to interstellar travel. And one of those is that we're very heavily biased by science fiction. And one of the issues in science fiction is you want to have a story involving people flying from planet to planet or star system to star system. They have to go fly off and beat Darth Vader or the Daleks, and then they have to be able to make it home for dinner, to have a good story. So this really requires something like faster than light travel. And so the assumption has become that you really need to have faster than light travel to be able to travel interstellar distances. Now, the fact is that's not actually true. You can travel slower than the speed of light and still travel at interstellar distances. The fact is that relativity works in your favor. The faster you go, the slower the time advances on your spacecraft compared to the rest of the galaxy, and so you can traverse these distances in reasonable periods of time. The traveler can traverse these distances in reasonable periods of time, whereas the people at home, this is going to take hundreds of years, many years depending on the distances that are traveled. So, for example, in the paper that the Max Planck paper, I actually put up an example here where I show what happens if you accelerate at 1,000 Gs, which is still less than what was observed by Senior Chief Day. But if you have a ship that can accelerate at 1,000 Gs halfway, and then you decelerate at 1,000 Gs the other half, you can literally get to Alpha Centauri in about 5 days. Now that's 5 days travel time for the person in the spacecraft. For everybody else on Earth, it'll be just over 4 years. So,
which is why you lean towards the nomadic model.
Yeah, so if you're going to travel great distances, you can, so at 100 G acceleration, which is on the low end of what I've observed in these cases, you can actually get across the galaxy in about 120 days travel time. So you're talking 4 months, which is faster than we get to Mars now. So one of these craft accelerating at 100 G halfway across the galaxy and then decelerating at 100 G, they're going to get up to very high percentages of the speed of light. They're not going to go faster than the speed of light, but they'll be going fast enough that relativity is really kicked in, and they can actually make it across the galaxy in a couple months. Now, for us back home, we're going. They're not. Let's say they go to the other side of the galaxy, some 80,000 light years away. And then they come back to Earth, so for them it's basically eight or 9 months later. For us at home, it's going to be 160,000 years later. And, this is, most scientists know that this is how it would work, but the general belief has been, who would do this? Why would you bother? Because nobody on Earth is going to get to find out what you learned, because you won't be back for 160,000 years. And one day when thinking about it, I thought, well, people would do this. People are right now signing up for a one-way trip to Mars with, SpaceX. People are crazy. we would do this. I wouldn't do it personally, but I'm sure I could find people who would do it. But then you could make it work if you all went in different directions and you explored the galaxy and you just met back here in 8 months. They'd be meeting back here in 8 months their time, but it would be 160,000 years from now. But so you would have to give up your idea of a home world. You don't live on a planet anywhere. You just travel. And if you travel all the time, you could form a nomadic spacefaring civilization. And nomadic civilizations are rare now on Earth, but they're not non-existent. We do have nomadic civilizations still on Earth, and they were more common in the past. So it's a very reasonable idea. So what I intended to do for that project was to basically model interstellar travelers, a whole network of interstellar travelers that basically travel and meet up and travel and meet up, and to see if there's a way to arrange meetup times and meetup points kind of in an organic or natural manner so that you don't have to pre-plan things, and to see if there's a way to design a network this way. And so on my initial experiments, yes, you can do it. It does seem to work. And, it's very possible that somebody may have tried this and may do this. And so a society like this would be really interesting, because their concept of biology would be very different than ours. They would study biology on an evolutionary scale. You could literally fly back and forth from one side of the galaxy to the other and keep coming back to Earth, and you'd revisit it every 160,000 years. So with less than 1 year of your lifetime. So when you're, if you lived for 50 years and you did this, you could experience about 12 million years of evolution on Earth, which would be fascinating.
I do have some questions from some of our listeners here. Let me go ahead and pull them up. It'll just take about 10 seconds. One moment. Okay, it looks like I have a question from a listener who said, why do ETs need craft at all? Just supposing that there are ETs. Why would they need craft at all, Kevin?
I don't know. I don't know what ETs are like, so I can't really answer that question.
Okay. And then, very good answer. And do you feel it's possible they could be altering the future is another question.
We all alter the future. I mean, that's what the future is. So I don't know exactly where the questioner would be going with that.
Right. Thank you so much for having answered that. And then also wanted to bring up, you talked about relativity, the general theory of relativity and when it would kick in. Can you go over that concept a little bit more regarding interstellar travel, please?
Right. So the idea is that time and lengths are observer-based. It depends on who's looking at them. So if you take a meter stick with a clock on it and you shoot that meter stick with a clock past me at very close to the speed of light, I'm going to measure the length of that meter stick as being very short. It's going to actually shrink in length, and the clock will move much more slowly. Now, conversely, if you're riding on that meter stick and you look at me who's holding a clock and a meter stick, you'll see that my meter stick is shortened and my clock is going more slowly. So when it comes to interstellar travel, you have two different perspectives you can consider. You can consider the perspective of the traveler, or you can consider the perspective of the people staying at home on Earth or wherever. From the perspective of people on Earth, I fly off to Alpha Centauri at 90% the speed of light. They're going to see my clock moving very slowly. So, of course, I make it there in a short period of time by my clock. So it doesn't seem so the traveler can make it there because their time is going more slowly. From the perspective of the traveler, the time is going normally, but because they're moving so fast, the lengths are shortened. So the distance between themselves and Alpha Centauri actually shrinks, and they then don't have as far to travel from their perspective. And that's basically how those two perspectives are different, but they both lead to the same results. They both lead to the same result of the traveler making it that distant in a short period of time.
I noticed in Constraints on Breakaway Societies Engaged in Relativistic Interstellar Travel, the paper that I guess it was a presentation that you did, wanted to know that you brought up, I can never say the scientist's name correctly, so you'll have to correct me, please. It's Dr. Frank, I have a problem saying Dr. Michio
Kaku.
Michio Kaku, yes.
Yeah, thank you. It always ends up sounding like a wild bird when I say it. I can never say his name right. Thank you. I noticed that you brought up a paper that he wrote, which is The Physics of Interstellar Travel. How did his essay on that, how did that, the article he wrote on that topic, how did it impact you? And why was it a good article?
Oh, I think I brought it up because he made the point that relativity works in your favor. And you don't often hear scientists admitting to that, whether they're not generally aware or realize that. I don't know what the situation is, but he actually highlighted that fact that relativity works in your favor, and he's absolutely correct. But he didn't go that next step, in that he stalled out basically where most other people have, where he said, but for everybody back on Earth, it's still going to take a long period of time, so why bother? Who would do this? And I think that's a short-sightedness on our part, not considering that, no, somebody who wants to do it will make it happen. They'll find a way to do it, and they'll find a way to do it comfortably.
Right, and I'm glad you brought up the idea of doing something like that comfortably, because I wanted to know what kind of materials do you feel hypothetically could be involved in building a ship to be able to handle going to an interstellar point?
Oh my God. Now this is where we go from talking about physical possibility to an engineering
Sci-fi? Okay.
engineering possibility, whether
Okay.
whether you could actually engineer something like this. So saying something's physically possible means that the laws of physics don't stop you from doing it. Um, whether you can engineer something that will work is the next problem. And the 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 biggest problems are radiation. You're basically going to have all the light's going to be blue shifted into X-rays and gamma rays. So you're going to be bombarded with X-rays and gamma rays. You're going to because for the traveler the distances are shortened and the distances shrink. That means that the hydrogen gas in interstellar space is not empty. You've got about one hydrogen atom per cubic meter. So once you shrink that distance, you're basically turning empty space into a wall of hydrogen gas that you've got to fly through at 90% the speed of light. And that's going to tear any ship to shreds in no time. So you really have to work on shielding and coming up with ways to handle shielding. And that I would have no idea how to do. There have been a few papers that I think I've referenced. I think I referenced on those slides in that talk. I talk about a scale of speeds at which travelers can travel. I'm actually going to pull it up on my computer so I can
good. Yeah,
not
please
forget
do.
what I'm talking about.
Feel free. Take your time.
Yeah, so I had come up with a scale for a traveler's scale. I didn't find the Kardashev scale, which is unfortunately Nikolai Kardashev passed away the other day.
I'm sorry to hear that.
Yeah, but he developed a scale that describes civilizations as using certain amounts of energy. But I came up with a scale of traveler classes, and there's a few papers by Semyonov. I think he's maybe at SUNY Stony Brook, Semyonov, but he has a paper on radiation hazards of relativistic interstellar flight, and he talks about the shielding that would be necessary. So for below 30% the speed of light, a titanium or aluminum hull of 1 to 2 centimeters in thickness provides sufficient protection against the flow of oncoming nucleonic radiation. But you're going to have a deterioration of the frontal part of the hull caused by intense micrometeorite bombardment with rate exceeding 100 relativistic dust particles per square meter per second, greater than 30% the speed of light. So things just get nastier as the faster you go. Once you get above 70% the speed of light, having a proton hitting your spaceship actually creates particles. So I mean, it's like you're flying through a particle accelerator at that point. So the engineering would be very challenging. Now the question is whether you can. So here I'm talking about travelers who are traveling at relativistic speeds using, conventional ways of moving, which is what, I really only considered in both of these talks. If you consider doing something like warping space-time, then you're playing a different game, and the game changes, and that's a different type of engineering, but that would require other technology.
Okay, Kevin, this might sound a little random, but you did say that there are serious implications for the Fermi paradox, since at any point in time, it is far more likely that any given ship will be traveling to its next destination. And could you please touch upon that topic?
Yeah, so if you have interstellar travelers who are traveling at relativistic speeds, so you're not talking about faster than light travel, then for those of us at home, it still takes hundreds of years for spacecraft to get anywhere. So if you're traveling hundreds of light years, so where where do you expect to find everybody? Well, they're all traveling. That's basically where they are. That's where they spend most of their time. They'll spend hundreds of years traveling, and they'll probably hang out on your planet for, even if they hang out on your planet for a year, they're still only spending 1% of their time on a planet with respect, from your perspective. Now,
Good
from their
point.
perspective, they're spending most of their time on planets, but from our perspective, they're all traveling. So that would be a possible solution to the Fermi paradox. Whereas everybody, they're all in transit. It takes forever to get anywhere.
Okay, so I'd like to get a little bit more personal about this topic because it's a fascinating topic, and I want to know, when did you first hear about the Fermi paradox, and why do you care about it?
Oh, I don't know when I first heard about it. I don't really care about it that much either. I don't see it as a paradox. It's only a paradox if you assume that nobody's been here. And we don't know that for sure because we've not studied it. So nobody knows whether anybody's been here before because it's not been scientifically studied by anyone. So you can't say it's a paradox. That's not a really appropriate statement.
Yeah, just for a little bit of background on the Fermi paradox, I think it's presented as it's a much more how can I put it, studied, sort of a formalized thing, when in fact it was really just came about from conversation at lunch among a few scientists, including Fermi, Edward Teller, and some others as well.
Right,
so
right, that's right.
They were just kicking some ideas around at lunch, basically, and it turned into something a little bit more than that. I mean,
except Fermi was very good at making important teaching points from seemingly innocuous statements. So so you could look at it that way, in which you then can consider, well, what is the teaching point? Well, that's not immediately obvious. It is the teaching point that, yeah, there ought to be aliens here. They ought to be here, so maybe we should look for them. Is that the teaching point, or is the teaching point that maybe there's a reason they can't get here and we should think about that? So
I wanted to bring up metamaterial research, which is interdisciplinary and involves fields such as electrical engineering, electromagnetics, classical optics, solid-state physics, microwave and antenna engineering, optoelectronics, material sciences, nanoscience, and semiconductor engineering. Do you think that metamaterials has anything to do with the building of a ship? And I do, by the way, before I finish that question, I still have another question for you about that topic, metamaterials. Do you think that metamaterials would be required in order to build a ship to go interstellar?
I don't know what would be required because I'm not an engineer working on the problem, but metamaterials seem to be useful for a great many things, so I can't imagine that they wouldn't be useful somehow.
Maybe for the technology on the ship, it's possible. But anyway, wanted to ask you, metamaterials is such a hot topic. It's trending in the UFO community probably all year, part of last year. It's probably been talked about a lot longer. But I mean, as far as trending and everybody talking about it, what are your thoughts on that topic regarding metamaterials and the UFO topic?
I think it's too early to jump to any conclusions. I think that we would do best by keeping all the hypotheses on the table until we have data to rule some out or to really support some. There are some materials floating around that are purported to be hull material from some of these objects, and these things look like they're metamaterials. Some of them are layered nanolayers of magnesium and bismuth, and that's interesting. These things have interesting properties, and whether they are, important or central, I don't think is known yet. It's also not known. It's also not been proved that those are actually hull materials from actual craft. In one case, these materials were sent to an investigative, reporter, and until we know where they came from and we can actually look at the craft and look at the equipment in the craft and know how the craft was collected, what happened to it, I think it's very difficult to say anything definitively.
Okay. And now TTSA has a project called the Atom Research Project. And what they do is they focus in on studying exotic materials for technology innovation. Do you have any opinions on that at all?
Yes, I think it's great that somebody's studying something for once. Instead of laughing, they're getting to work, which is an important thing to do.
Good.
I find it frustrating when I see professional scientists making professional statements without having done their homework. And I think that's, I saw a video where Stanton Friedman, expressed his frustration with this, and I share that frustration. And
Yeah.
I'm really glad to see scientists doing what they do best, study it. And
Well,
then
let me
once you've learned something, tell us what you've learned.
let me jump in real quick, Professor, and ask you this. So let's say that your friend Joey had, during his sighting, picked up a fragment. Hey, this fell off the UFO that I saw, Kevin. And if you got your hands on something like that from a source that you find credible, what would you do with it?
I'd look at it. I'd study it. I'd go do X-ray fluorescence on it and find out what elements it's made of. I'd put it in an accelerator, or and look for the isotope ratios. I'd use Raman spectroscopy and look and see if there's carbon nanotubes or any organics present. There's a lot of things you could do, and it would be a great fun. And in fact, I'm in contact with two separate individuals at this point, and we're discussing, the possibility of me looking at some of this material. So.
Oh, okay.
So I think that's an exciting thing to do. I think it's something that we scientists ought to be doing, and that's important. It'll add to the body of evidence that will have to slowly build up as we slowly come to terms and understand what these things actually are.
Yeah, and I'm glad you brought up the word evidence, although I know it's been used frequently throughout this discussion, off and on. The idea of evidence, facts, and proof, and then let's just throw in for good measure, what is good data? So those four things. Can you please tell us, in your world of science, what do facts, evidence, good data, and proof mean?
Well, facts are things and evidence is closely related to this. Evidence is something usually based on something that you can measure or have measured. Good data is data that allows you to make rather definitive inferences from the data alone. So if you have, that's basically what we mean by good data. So when you have sufficient data that you can make the inferences you want to and say something definitive about whatever you're studying based on that data, that's good data. It's usually not the case that your data is very good, and a lot of times in science you are working with what you mean by good data changes. So I also work with exoplanet detection, and in that case we've taken data from the Kepler Space Telescope that I think you put a picture up earlier that showed the Kepler looking up at the sky near the constellation of Lyra and such. And basically the Kepler Space Telescope would watch stars for several years and basically record their light intensities. Now, when you have periodic decreases in light intensity, you can use that to infer the presence of planets. Now, if you aren't knowledgeable about how planets orbit stars, you could argue that that's really pretty horrible data and horrible evidence for a planet, because what if they're sunspots? What if it's something else? And sometimes that happens. Sometimes we need data from another source. So very often, that's actually why we have two categories. You have exoplanet candidates, and then you have discovered exoplanets, and they're different. Candidates are exoplanets that have been detected using one imaging modality, maybe light from Kepler. And then what you would do is you basically would go and say, well, let's look at that star, more closely. Let's record spectra from the star and see if we can detect the star wobbling and perform what are called radial velocity measurements. And then once you've got radial velocity data along with the Kepler data, then you've confirmed that there's a planet there. Then people will feel relatively secure that, yeah, it's probably a planet. So, so those are all difficult issues, and in this topic, it's extremely difficult. You're studying a phenomenon that you can't control, and a phenomenon that does not happen regularly. So those are the hardest things to study, and traditionally these have been very difficult areas. And I remember back when I was at NASA Ames, I was in a poster session presenting some of my work that had been funded by the DDF, which was a discretionary director's fund. We were modeling planetary nebula. And I was at the poster session, and the poster next to me was from another scientist who was also funded in the same program. His name was Friedman Freund, and it was a poster on earthquake lights. And I had never heard of earthquake lights, so I kind of looked at his poster a little bit, and talked about earthquake lights as being lights that appear above the ground during earthquakes. And his poster was mainly on how rocks can conduct electricity, and under large amounts of pressure, you have piezoelectric effects that create high electric fields and such. And it looked kind of reasonable, but I kind of was talking to a friend of mine, and a couple of my other friends came by, and I said, this is an interesting poster over here. What do you make of this earthquake light stuff? And they were all pretty much the opinion that said, oh, that's Friedman Freund. He's kind of nuts. He's been going on about earthquake lights for years. People apparently have been reporting lights during earthquakes, for centuries, and he thinks they're real things, but they're probably just people under psychological stress from being in an earthquake. And so, a couple of my friends said all the same thing. They all thought he was kind of crazy. And so I went over and talked to him and had him give me a walkthrough, and it seemed reasonable to me. It didn't seem very far out. He had explanations for everything, and he wanted to study these effects because they would, if you understood this, then you should be able to detect the electric fields before earthquakes happen, and you could develop earthquake detection systems, which I would imagine people would be interested in. But he had been unable to get the interest of anyone from the American Geophysical Union, and he was quite frustrated. And he was quite old already at that time. And so I was glad just a few years ago, you can Google earthquake lights. And just a few years ago, there were two earthquakes back to back, and security cameras had picked up earthquake lights in both cases. And so people became pretty convinced that these were real things. And so, of course, this hit the news and was all over the news. And who did they go to? Well, they went to the only expert in the world who knew anything about earthquake lights, which was Friedman Freund. And I was really glad to see that he was still around to be able to enjoy the fact that he was vindicated. He was absolutely right. But the problem is, how do you study something that you can't control? He doesn't know where the next earthquake's going to be, so he can't set up equipment to measure these things. And that makes it very difficult. You have to sit around and wait until you can get data. So it becomes a difficult game. I also think about it this way. I think about supernovas. We still don't understand how all supernovas work, right? But we have plenty of evidence that there are supernovas. However, imagine that supernovas were maybe 100 times rarer than they are, so that you would only see them once a century. Well, we could have gone the last 100 years without seeing a supernova, without it being recorded by, modern telescopes with CCD cameras. And do you think astronomers would believe in supernovas based on the Chinese reports and, in the year 1000 that made the Crab Nebula, or Tycho Brahe's report? Yeah. Do you think scientists would have believed that there were such things as supernovas based on that?
Right.
I'm not sure they would. I don't think anybody'd believe it. So what constitutes good evidence is really difficult, and it depends greatly on what you know already, which depends greatly on your models. So we have excellent models on how planets orbit stars. We know all about this, and so these little light dimming events that you get from Kepler, I think, constitute excellent data. But from somebody who doesn't know anything about planets orbiting stars, they would think it was pretty crappy data.
I wanted to ask you about quantum physics, and do you ever have to, does quantum physics or any type of quantum subject matter enter into anything that you do research on?
Yeah, I do. I do work on quantum foundations. So basically, I work on deriving some of the basic laws of quantum mechanics, what are known mainly as the Feynman rules and the Born rule and things like this, on how you do computations in quantum mechanics.
Okay, and then wanted to know, do you feel like Einstein had this might be an understatement, but a real issue, so to speak, regarding quantum physics? Was it a nightmare for him?
I don't know. I mean, quantum mechanics was weird, and I think that and nobody saw it coming. So it was a surprise to everybody, and people still struggle with quantum mechanics. Professionals still struggle trying to understand quantum mechanics. So I think he had as much trouble as anybody else did.
Yeah, I actually have a wonderful book here called Genius about the life and science of Richard Feynman.
Oh, is that by James Gleick?
Yes, yeah. It's one of my favorite books. It's very very worn out. Wanted to ask you, wanted to make a comment. I was watching a documentary on Feynman, and I believe he said something to the effect of a class he was teaching about quantum physics. He kind of laughed because he said, "We really don't know what we're talking about. We don't know what we're teaching."
Right.
How do you feel about that?
No, I think that's in some ways that's correct. I mean, we know a lot about quantum mechanics, and we certainly know how to use it. We know how to mathematically describe what's happening. We know how to make predictions, and that's very practical. But we don't have a good idea of the theoretical underpinnings and why those mathematical relations should hold in those cases, and why you should be doing the calculations that you need to do. That's where it gets to be really difficult.
So is quantum entanglement a big part of that weirdness and makes it difficult to understand?
Yeah, it is a big part of that weirdness. It is weird, yeah. And although we're not supposed to say that as scientists, we had written a paper. Two colleagues and me have written a paper on deriving the Feynman rules and sent it to PhysRev. And in the introduction, we said that quantum mechanics was strange, and we were scolded by the reviewers for describing any physical theory as strange. We think that they said that was unprofessional, but well, whatever.
Yeah, just real quick also with your astronomy background, we've kept you a little longer than we were originally planning, but
that's fine.
Things have really moved on at a good clip. I posted a story at my UFO group regarding the Big Bang Theory today, and it was asked like how do we know? And I don't really believe the Big Bang Theory. This was one of the commenters, and I wanted to ask you about the Big Bang Theory. Basically, what I think is could be, I guess, best described as a theory regarding the beginning of the universe. I'm sure that's not quite correct, but can you go into a little bit about that, and how did the theory come about, and what is it based on?
Oh, that's tough. That's not really my area of expertise.
Okay.
I mean, I know a little bit about this, but I don't know a whole lot about the details. The basic idea is that the galaxies are observed to be accelerating away from one another. And so the universe is expanding. And so that suggests that it was once much smaller. That's basically the idea of the Big Bang. Now, there's then the whole field of cosmology works on studying how a universe evolves. A lot of this is based on the formulation of general relativity and how things expand under gravity. How does gravity make things expand in addition to attract? Right. This is the interesting thing about the theory, and And then you have to worry about what the universe was like in the early stages. And, we have theories that describe what all this should be like. And we look at the current state of the universe to see if those ideas are actually supported with what we think it probably looked like earlier. So if you have a theory of what it looked like in the beginning, you should have some idea of what it looks like now. And that's how you can work to verify these theories. So there is a body of evidence much greater than just the expansion of the fact that galaxies are moving apart that supports the idea of the Big Bang. Another piece of evidence is the abundance ratios of the elements, the fact that most of the universe is hydrogen, and then you've got helium and so on. But those actual ratios are actually predicted by the Big Bang theory as well. So as well as other pieces of data.
Before we wrap this up, I have a question for you that has really annoyed a part of the UFO community, and that is it's sort of a rampant bad habit of various groups of some people and some organizations who come forward to making claims that they have found certain scientific discoveries, but they never have any scientific data or reports to back up their claims. So what are your thoughts on folks who are making claims that they have some kind of scientific breakthrough or scientific discovery about some topic, but they don't have any data or reports to back up their claims? What does one do about that? How do you respond to something like that?
I don't know how you respond to it. You just can't possibly believe it without data. That's really the problem.
So then let me go ahead
it's not supported. So they don't have any support for their statements.
So then, okay, let me go ahead and narrow it down a little bit more. I'll give you an example. TTSA. I don't know, Frank, do you think it's been for a year now, maybe longer?
Well, it's been longer now. Yeah, it's been over a year and a half now.
Where they have actually made claims, like, for example, and by the way, I'm not putting them down. I'm just being factual. Lou Elizondo, for example, when he went to the SCU this year, which is the Scientific Coalition of UAPs studies, he actually did a talk on metamaterials, but he did not have any reports or data to back up his science, to support the science of what he was talking about, the scientific breakthrough or whatever it was he was mentioning. And TTSA seems to have a pattern of mentioning or teasing the public about things that they might be onto or discovering, or something that they're doing research on, but they have no reports to back it up. Do you have any perspective on that?
Yes, I think this is something I've noticed and worried about. I had hoped that TTSA would spend some effort performing scientific research. And that involves collecting data, which they appear to be doing, and basically then reporting their findings and discussing openly with other scientists, which they're not doing, or at least not that I know about. So that was, quite the case when we were at the SCU meeting. We had, discussions with many questions where there were answers unable to be given, whether this is going to violate, somebody's non-disclosure agreement, or whether it's going to disclose too much that's going to jeopardize the television show, which was implied at one point. But as a scientist, this is frustrating because we don't care about TV shows. We care about non-disclosure agreements. I understand that. But then in that case, the claims you're making are unsupported, and that they're going to be treated with a grain of salt by the scientific community because you're not presenting evidence. And we need to see evidence. We need to see evidence. We need to see the train of logic that led you through the analysis and allowed you to make the inferences that you made from that data. That's very important. And I think that sharing information with other scientists is paramount in the scientific community. And this is something that I haven't seen TTSA really getting involved in, which I had hoped that they would do. Whether this is from their wanting to keep things close to their chest, for, their own gain, or whether, it's the whole non-disclosure issues resulting from people's previous employments. I don't know what that is, or maybe it's just an atmosphere of them used to working in a situation where they don't share data. I don't know precisely what the situation, but I would really hope, and I would be very enthused if they would share more data and be more open.
Okay.
Well, when you get your hands on these possible ET fragments that you discussed earlier, you'll share with us. You'll tell us first, right?
Oh yeah, no. I mean, I haven't signed any non-disclosure agreements with anybody. I'm gonna write up my work and I will publish it, and I will give you all the gory details of the analysis I did. To the point where you can't stand it anymore. But that's what we do. I mean, that's how you do it.
So I asked TTSA, not that they listened, I'm not saying that, but I publicly asked TTSA to please share any reports or anything to back up the claims that they're making. And I was met with such hatred from certain fan groups of TTSA that are totally I guess you call them fanboys. They're totally devoted to TTSA, which is fine. But the reaction I got was they were outraged that I would ask for that. And I was told by a certain person in the UFO community, I won't mention names, that I should feel lucky that TTSA has gotten us as far as they have regarding the topic of ufology, because they've progressed and put us in a direction much farther ahead than anybody else ever has in the 50, 60 or whatever amount of years ufology has been around, and leave it at that. But see, that's not satisfactory enough for me.
Well, it's not. It's fine. They can do whatever they want. That's the truth. But they can't call it scientific research if they're not going to engage the scientific community scientifically, and that means sharing data, sharing information, and that. And so, if they're not going to do that, then it's not scientific research, and then those claims are just wrong. And I don't think any of us should feel lucky at this point. I'm going to reread. My response to a statement like that is I'm going to reread one of the sentences from my conclusion, and it is, ironically, such attitudes inhibit scientific study, perpetuating a state of ignorance about these phenomena that has persisted for well over 70 years and is now detrimental since answers are presently needed. There's no reason that we should be this ignorant about this phenomenon, and this is not safe. And so I think we need to move past this.
Okay, so then
earlier, let me jump in.
Just one last question, and then I'll leave it alone. What do we do if TTSA never brings out anything to back up the claims that they've made? What then?
Well, then you hope that scientists like me and and those at SCU make progress, and because we are working to do things properly, scientifically, out in the open, where we can all learn from this.
Okay, thank you.
Yeah, you had mentioned getting hold possibly of that possible ET fragments, possible ET material. What do you think your turnaround time would be before you were able to say, I can't figure out where this is from? How long do you think it might take?
I have no idea. Yeah, I can't really predict that.
Okay.
Yeah. It depends on all the other projects I've got going on at the same time. Like I told you earlier, I do too many things, so that's hard to say.
Okay.
Well, I thank you so much for your time tonight. You've actually taken a lot of discretionary time to spend with us at such a late point in the evening also, Kevin. And Frank, did you have any more questions?
We are good.
Okay, yeah, Kevin.
Great, thank you.
It's late here in the
East. For having me. I really
Thanks a lot, Kevin. I appreciate it.
It's been a lovely evening. It's been very enlightening, extremely educational, and also, I just thank you for allowing us to just ask you any question. You've been just so kind, in allowing us just the luxury of being able to spend this kind of time with you. So thank you so much.
Oh, thank you so much for having me. I really appreciate it, and I enjoyed myself as well.
And before we go, I did want to ask you, where are you going to go this year? Are you going to do any talks? I'd like to at least let our listeners know if you're going to travel anywhere, to do any talks on anything. And if you are, where are you going to go, and what are those talks going to be about?
Oh, well, let's see. I will be going to the next meeting that SCU holds. I think that's going to be in mid-June of 2020. I'm going to be at there's a Quantum Foundations meeting in Växjö, Sweden, which is in typically early June. Or actually, I think it'll be right after the SCU meeting. So I'll probably actually go from Alabama to Sweden. So I'll be talking there. And I'm also planning on going to the Max Planck meeting. I go to those almost every year, though. That one will be in Austria in July of next year.
Fantastic. Thank you so much for your time tonight, Kevin. It's been a real pleasure and privilege.
Well, thank you so much. I've really enjoyed myself.
All right, and we are out of here. It is late in the East, so it's past my bedtime. Got to go. We'll be back Tuesday night with Derek Gilbert. So good night, everybody. Thanks a lot.
Good
Bye-bye
night.
now.
Thank you.
Good night. Thank you.